So what we're going to do now is solve a system of equations, but not by graphing like we did in the last section. We're gonna use what's called the substitution method. The substitution, which we want to use anytime you have a variable by itself. So right here we have y equaling 3x minus 4, and we all have y equals negative 2x plus 11. Because we have a variable by itself, I'm going to substitute this part in for the other y, because that's what y equals. So if I go 3x minus 4, and I put it where the y is, I still have it equaling negative 2x plus 11. I now have an equation that I've eliminated the y's because I've substituted. And now I can solve the equation by adding my x's to one side, 5x minus 4. Then I go through the process of solving, and I end up with x equaling 3. So once I have one variable, I can then substitute it back in to either one of the equations. So I'll put the 3 into the first equation, so y equals 3 times 3 minus 4, which is 9 minus 4, which is 5, so y equals 5. So I've solved the equation. So I've solved the equation by eliminating 1, and I'm doing it by substituting. So let's look at this example down here. I don't have a variable by itself, but I can easily move the plus 7y over, the minus 7y over to the other side by making it a plus 7y. So if I change this by just adding it to the other side, I now have a letter by itself that I could substitute in for the x in the other equation. So I'm going to substitute the 7y plus 11 where x is, and then just solve this equation. So if I solve this equation, I'll distribute 35y plus 55. So I just distributed plus 4y equals negative 23. So I combine my like terms. These are like, so that's 39y plus 55 equals negative 23 minus the 55. I would get minus 78 equals 39y. So y will equal a negative 2 if I solve that. So now I just substitute this negative 2 back into the y up here. So x will equal 7 times negative 2 plus 11, which is negative 14 plus 11, which is a negative 3. So x equals a negative 3. So my answer is negative 3, negative 2. And so I've solved the equation by substituting. Let's look at this last problem. I have a y that's not by itself, but I can easily change it to y equals by changing the sign to a minus 2x plus 7, and I can substitute now this in the other equation for the y. So I have y 5x minus 3, and I substitute the minus 2x plus 7 because that's what y equals, and then just solve this equation. So if we solve this equation, I would have 5x, I distribute, that's plus 6x, and then minus 21 equals 23. I combine my like terms, so that's 11x, and I add 21 to the other side, equals 44. And if I divide, I get x equals 4. So now that I know what x is equal, I could substitute it back up into this equation. So if I go y equals a negative 2, the 4 plus 7, it's a negative 8 plus 7. And so y will equal a negative 1. So my answer is 4, negative 1.